Hello and welcome to today's webinar. Thank you for standing by. All participants are in listen-only mode. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Jennifer King, editor of Pumps and Systems Media. Today's topic, getting the most out of your pump in CIP versus COP applications, is sponsored by Unibloc Tech. Today's presenter is Pella Olson, National Sales Engineer with Unibloc Tech. Pella has over 15 years of experience in multiple disciplines, including food, beverage, pharmaceutical, chemicals, oil and gas, and renewable energy. He has served in numerous roles at Unibloc Tech, including project engineer, quality assurance engineer, and sales and applications engineer. The presentation today will be about 45 minutes with time for Q&A at the end. Please feel free to enter questions in the Q&A or chat feature throughout the presentation, and we will try to get to all of them at the end. If we are not able to get to your question live today, the folks at Unibloc will get in touch with you later. Also, if you're interested in a certificate of participation for today's webinar, please email me at jdking@cahabamedia.com. I will put my email address in the chat box now. And now we will get started on our presentation.
Hello, everybody, and thanks for tuning in to this session here. My name, as mentioned, is Pella Olson. Worked for Unibloc for some 11, 12 years. And today I will try to share with you a little bit what I have learned throughout those years. And there is a lot to learn, and I will probably just scratch the surface, but hopefully I will give you some good pointers what to think about in regards to COP and CIP applications and pumps. Going to skip forward to the brief agenda. What we'll go over will be a little bit on the regulatory requirements. Then we're going to talk about CIP versus COP in regards to the operation. The CIP, COP in regards to the equipment and specifically low pumps. What type of design considerations to keep in mind, and what to think about when you do select the pump for your process. And at the end, we're going to scratch a little bit on the maintenance tips on low pumps as well. Starting off with the standards and regulations, and why do we have those? Yeah, it's of course to keep the people safe. FDA is something that most people heard about, the Food and Drug Administration. That could be considered more being a reactive type of regulation compared to a newer version is called the FSMA, which stands for Food Safety Modernization Act. And that is considered being more of a preventive regulation. And that is something that was put into law in 2011. And the word out there is saying it's the most sweeping reform of US safety laws in 70 years. So that is something to keep in mind. On the dairy side, we have the USDA, which is then the US Department of Agriculture. That's what the dairy industry is more focused on. And these standards and regulations, they do talk about how to grow, pack, process, and import produce. We're going to focus a bit more on the process side. We're not going to talk about how to grow and pack and import in this session. Then on the equipment design and sanitation, there are the standards 3A, which is a sanitary standard on equipment. And on the sanitation, you will hear about the 21 CFR Part 117, which then address the a good manufacturing practice hazard analysis, and it's a risk-based preventive of controls of human food. And these are to help you out to avoid situations like you see here on the right-hand side. There are cases not too long time ago, there was a huge recalls of 8.5 million pounds of chicken. That's a big cost to a producer. And it could be even worse, that you can be legally fined as a scenario 2016 in a peanut butter plant, $8 million criminal fines plus 3.2 million of valuable in assets lost. So we want to help you avoid these scenarios becomes yours. Looking into the cleaning and sanitation focus here in the 21 CFR Part 117, that is, has procedures, practices, and processes to control food allergens. And we will dive into the sanitation aspect of it. And there you diving deeper into a subcategory, which then is called 117.135. That one addresses the prevention of cross-contamination and also the cleanliness of food contact surfaces. And here you're going to have a couple of definitions, such as the cleaning. The definition of cleaning is the removal of soil particles from surfaces by mechanical, manual, or chemical methods. And then the definition of sanitizing, disinfecting, sterilizing, and dirty. For example, you cannot sanitize a surface that is not clean. You have to clean it before you sanitize it, as an example. In the food industry, we're going to hear more about the sanitizing. In the pharmaceutical, you're going to hear more about sterilizing in that market. Cleaning and sanitizing, the different ways or methods, the ones we're going to focus on here are the two main ones, the CIP, clean in place, and COP, clean out of place. But there are two other methods as well, it's called foaming and spraying, but we will not go into that in this session. There are a couple of basic issues when it comes to cleaning and sanitizing. They are then summarized in an acronym called TACT WINS. And these are 8 elements to then be considered when you do develop your cleaning program. And they stand for T for time, A for action, C for concentration, and T is temperature. And then WINS will be for water, the individual, the nature of the product, and then the type of surface that needs to be cleaned. Looking at the CIP, clean in place, the pros and cons on this type of method. If you have identified which method works best for you, and the CIP or one preferred method. But the advantage with this method is it's an automated cleaning, and you don't have to remove plumbing or piping. The next advantage would be the labor involved in this is less, so you're going to reduce costs around the labor. It's considered being a faster operation since it's automated. You also going to gain that the equipment damage from disassembly, since the equipment doesn't have to be taken apart for cleaning, then you reduce that risk. The downside might be then the cost. You will have to invest in additional pumps, tanks, and piping to provide this solution. There is also in the previous slide from TAC wins, where they have the nature of the product. Now, all products that are not easy to clean at all, and the CIP solution may not be your end solution there. So some products cannot be cleaned with CIP. Drainability, something that you get a budget in there as well, or think about that once you run through your cleaning solution, you have to make sure you drain that out so you don't have that left in the pipe. And it comes with a little bit more complexity on the system. You have about 5 to 7 steps in the sequencing, and you have to make sure all the equipment is calibrated to be able to perform what it intended to do. In the CIP world, there is a rule of thumb of the velocity that is required to clean out the equipment in the pumps and pipes. That rule of thumb is 5 feet per second in the pipe. And that is, we simplified that here to translate that to a flow measurement in regards to gallons per minute. That equals to about 24 gallons a minute. So you may have a scenario where you have a pump is producing 10 gallons a minute of product, but you have to generate more than twice the flow, 24 gallons a minute of flow rate to reach that velocity that is required to clean out the system. That's why you, in most cases, need an additional pump or a booster pump to create that extra flow. If you compare this to the COP clean out of place, the advantages with this method is that the method is actually done by friction. It's a manual cleaning that physically removes the dirt or the soil, and versus a CIP, which is a contact-free or contactless method. And you can consider in your own household where you run your plates and bowls and utensils in a dishwasher. That is your CIP system in the house. And I'm sure we've all seen when the plates are not being cleaned or the bowls not being cleaned out with a dishwasher. And that is basically because either you position them wrong and the CIP fluid or the washing fluid did not access the bowls proper. So that is the same thing in the process plants. If you have equipment that has a very unique design, then the CIP system may not access that properly. And here you can see in a lower picture here, I actually took from my own example here, that bowl has been run through the dishwasher, but you can still see signs that there is dirt left on the bowl. So even the CIP system did not work. So I had to manually scrub it afterwards. So the other advantage would be that the capital expense, the initial cost is less. You don't need the additional piping, tanks, etc., and pumps. And the nature of product, that was a concern in the CIP. You don't have to be worried about that here, since you will manually see it and you can manually add that friction method to clean out the equipment. However, there are disadvantages, and that is there is an additional potential cross-contamination. You have more workers involved, so that comes with a cross-contamination risk. There are higher labor costs. You potentially going to have an additional sanitation crew that would take care of the cleaning or the sanitation. So that's going to be a labor cost involved. Training, you need to have extra training for more people, and there's going to be a different set of people perhaps. It's probably not going to be a technician that will do the cleaning. You're going to have more of a sanitation crew, so they also have to be trained on the equipment. And safety, you are moving around equipment, you do take it apart, so with that comes also a portion of the safety concern. Skipping over to the equipment design, that is then ruled by the 3A standards. Focus starting on the CIP design equipment. What to think about when you select the pump here is to find a very hygienic and a clean design pump, and look for pumps that are crevice-free. As I mentioned before with a dishwasher, the simpler design, the easier the CIP fluid will access around and inside the pump. So you don't have food product left inside the impellers, for example. The hardest part of the pump to clean is behind the rotors. There is a tight space there, so you have to make sure that the CIP fluid access behind the rotors as well. On the material of construction, 316L stainless steel is the industry standard, and you will get really far with that. But in some partial chemicals and other applications, you may need to go on a higher grade level of stainless. The surface finish at a minimum should be 32 RA. Some applications require higher surface finish, and that is typically more in the biotech and pharmaceutical. The compatibility, the EPDM and FKM are industry standard, and you will most likely be fine using those, but there are also applications where higher grade elastomers such as Calres may be required in order to be compatible with the application and also with the type of cleaning solution that you will go with. You have to consider or think about the tolerances in the rotor and the pump, because when you run the product, you may run at one temperature, but when you do the CIP, that temperature is going to be at a higher temperature. So that comes with expansion of the rotors. So you have to allow for that expansion rate to take place, so you don't have a galling situation due to that. And make sure you have enough access around the impellers. It's a balance between the temperature and the efficiency of the pump, because the larger tolerances in the pump, you lose a little bit of performance, but then you gain the cleanability around the impellers. But then the drainability, most pumps then might be oriented in a vertical position to have full drainability. But that's something you want to make sure of, that the pumps and equipment are being drained proper after your CIP cycle. And here you also want to make sure that after you've done your CIP, you want to, in the beginning, validate that the CIP is functional and in doing its job. And that can be done with a swab test that we're probably familiar with now, a swab test from the COVID era. But that is also in the process plant, that you swab the equipment and you test it with an ATP type of method that is producing a glowing light and identify potential bacteria left in the pump. There, I cannot stress enough to then seek up equipment and pumps then that are crevice-free when you do CIP. And we have an example here from a peanut butter processor plant that they were experiencing a lot of issues with with the application. They had a pump with crevices, especially this case was in the rotor bolt location, that the peanut butter was not being cleaned out, or it was not being recirculated. It got stuck in that crevice, and it was building up and hardened, and it got so hard that it broke off the rotor bolt, and you had to chisel it out just to get it out of the area. And that is not good, and it will both be unsanitary, and it will also damage the equipment and cost you a lot of money. So by a simple design, a flat front cover with fewer crevices did solve the problem. No longer have to chisel out the peanut butter, and equipment lasts longer. So something to keep in mind there. I mentioned before, another part of the pump that is difficult to clean out the area behind the rotor. And the reason for that is because it's such a tight tolerances. There is not a lot of gap behind it for the CIP fluid to go behind the rotor and access and properly clean out that area and the seals that are then positioned behind the rotor. But there are features that could be added on, such a CIP slot is what we can call it, that you can see here. I tried to show that on this image. It's a slot where you supports the CIP fluid to get behind the rotor and clean out that area better. And that is something we experienced in a liquid egg process plant. They were using a pump with, again, a lot of crevices and super tight tolerances. And they were doing CIP, yet the USDA inspector, he did not trust, or he could not validate that the pump was being cleaned out proper. So actually the way they were operating at the time was to run the product, start the CIP cycle. Once the CIP cycle was done, they had to open up the front cover and actually undo the rotor bolt and remove the rotors. And then if it wasn't clean enough, they'd have to manually continue to clean further, while the USDA inspector was on site and then approved that the pump is now clean. You can put it back on and continue your process. So what we ended up doing here was actually to implement this additional feature here with a CIP slot that allowed for the CIP fluid to easier access around the rotors. So the end result here is that the first few runs after CIP, they remove the cover, they remove the rotors. The USDA inspector, he looked at it 2-3 times. He validated it. The pump is clean. It looks pristine. And the way to do today is still they open up the cover, but they only visually have to look inside the pump and look for other damages. But they no longer have to remove the rotors. So that's a big step forward for them. Switching over to clean out of place equipment, you still want to find a pump that is hygienic and have a clean design. For example, the concern about getting clean behind the rotors, you don't have to worry about that anymore. Since the rotors are going to come out, then you will make sure manually that you're cleaning out inside the pump there. The material construction, the 316L is still going to be your industry standard. However, you do open up for alternative material, such as an FDA polymer that can be then either X-ray or metal detectable, depending a little bit what you have for detection system downstream. But these type of materials can be used on the rotors, for example. And the advantage with that is that they are free floating, so to say, inside the pump. They don't require a roller bolt. So when it comes to taking the rotors out, it's a much simpler way for the sanitation crew or the operator. Compatibility, EPDM and FKM is still going to be your industry standard and go-to elastomer. On the temperature changes, you're not going to have that in a clean out of place situation. So that concern is now being removed. Drainability, the port orientation doesn't matter as much, it doesn't matter anymore. You're going to drain it manually. But then what you want to look for here, if you're going to have a pump that is taken apart manually, you're going to want to look for equipment that requires fewer tools, has fewer parts, and have some safety features built into it still. Pay attention to that. On this slide here, you trying to illustrate a scenario where you have two different type of pumps where both pumps are used in the clean out of place method. The top picture there is a low pump that is designed for COP, and the lower image then is a different type of pump that is used for COP, but it's not really designed for that purpose, because if you have to take the equipment apart, you want to make sure you have few components to make it easy. And the pump below there is very complicated compared to the pump on top there. And here we have an experience with an ice cream plant that they reached out to Unibloc, and he explained his situation that the plant had a 2-year shutdown because of listeria outbreak, and they now were going to start over fresh, and they came to the conclusion that CIP is not going to be their method. They're gonna operate with COP because they were not trusting the CIP enough. So he was seeking up equipment that was the best and for this purpose and way of operating, and he wanted to go over and above the industry standards. So we worked in deep detail with this engineer to find the right solution for him. We tweaked the design a little bit, but eventually we found a good solution for him with a pump that was perfect for COP, with a seal that was easy to change out and to verify is being cleaned proper by between each batch. So today they are in operation since about 4 years, and so far so good. This slide is to compare two similar pumps, two low pumps, where one pump is designed for CIP and one is for the COP. The top one is the typical pump, a conventional low pump, CIP, where you will have, if this pump is used for clean out of place application, which is happen a lot of times, there you're going to have 10 parts to take apart, compared to the bottom image is going to have 4 parts. And sometimes it could be even 3 parts because the front cover O-ring may not be required all the time. So fewer components, the better in COP. And this is something that the meat, poultry, and pet food plants, they are looking for this all the time. They do clean once a day. And when they have a low pump that is designed for CIP but used for COP, you're just going to have more parts, more problems. So they look for a low pump that is designed for COP that you can see here. It's frequently used there. I want to circle back to one of the disadvantages with the COP, and that was about the safety concern. That is not to be forgotten about, but what you can do here is to look for pumps that have a little bit of an extra safety feature. Some pumps does not require this, but when equipment gets bigger and heavier, especially on the front cover, if you're gonna have to remove the front cover every day, then there are sanitary assist swing arm or safety swing arm that helps out with this aspect. So when you loosen those bolts, it doesn't come down to the floor, so you don't have to worry about it dropping down on anyone's toes, and you're keeping it away from the floor. So it makes it both safer and cleaner. We at the Unibloc, we estimate that the main damage, or the sanitation crew, they are the ones that are most responsible for the damage of the equipment, up to like 90% of the pumps and equipment. So I can't stress enough to look for pumps that are simple to clean to avoid additional damage that is not necessary. And that is because they are not as experienced with the equipment. They don't care as much. They don't understand the value of the equipment. So simplified for them. If you can remove tools being required when you take the pumps apart, the better. You're going to save repair costs, and that's going to eventually lower your total cost of ownership. And if the sanitation crew have an easier way of doing their task, then they also will perform in the task what they supposed to do, instead of making it complicated. So if they do perform the task, the equipment will be cleaned out the way it's intended to be, easier and better. So therefore, you're going to reduce that risk of potential recalls that is then caused by either bacteria or foreign material, for example. And also the cleaning time. No tools required, easy to clean, easy to disassemble. That's going to reduce your total cleaning time. And I want to highlight that most of the low pump manufacturers, they have one design pump, and that is a CIP design pump with a lot of O-rings and elastomers to meet that standard. And that is being used then in COP applications, but that doesn't have to be the case. If you can find a pump that is actually designed for the COP, the better for you. Switching over to a little bit on the maintenance side, and what I have learned so far in the maintenance side, typically, of course, you're going to have a preventive maintenance schedule, PM. That is, of course, critical. But what we have seen in many cases, pumps being sent in for repairs, they come back without any gear oil. So it's just like a car. You have to service the car. They will not run without motor oil. Same thing for a pump. They have to be lubricated. Make sure you check that or refill it or change it on a regular basis. A couple of other things is to pay attention to sounds and leaks. So if you have the pump is making a new sound, that typically means something has changed, something is going on. So then address that, the sooner the better, before things escalate and it's getting worse. Same thing with the leaks there. A small leak, typically a sign that something is wrong. Take care of that right away before it gets a bigger leak and then creating bigger damages. And when you do inspect the pump as well, look for galling. If you have small scratches, that means the rotor is touching the housing or the front cover. It can start small, but it can very quickly escalate as well. And the sooner you address that, the better for you. You're going to save the repair cost that way. And here's one thing that some people are not aware of, and that is the rotors, the stainless steel rotors in a pump. They have a unique precision. They are meant to fit on both locations, but it's a good rule of thumb to follow that if you're removing the rotor from the shaft, make sure it comes back on the same shaft. That way you're going to prevent potential problems. So top rotor goes back on the top shaft, for example. If you service the pump and you put it back together, double check the rotor clearances. Make sure you have enough tolerances behind and in front and around the rotors. Make sure so they don't touch and scratch or gall the pump. Pay attention to the torque and tensions that are in the pump manufacturer's manuals. They are there for a reason. If you torque the rotor too much or too little, then the rotor is going to touch either back the housing or in the front cover, and then you're going to end up in a bigger problem than you need to. Then there is one thing on the motor alignment. That's also something that cannot be forgotten, that once you have the pump out of service, you're going to put it back on with the motor. Then it's important that those two pieces of equipment are aligned proper. Otherwise, you will end up having excessive vibration, which will then have premature failure on the pumps and the bearings. So I'm going to show you an example here on a video where you can see a pump and a motor that has not been properly aligned. And I'm going to play that for you here. On the left-hand side is the motor, and you see there you could see the motor was vibrating pretty heavy. That will then lead to bearing failures of the pump and create a higher repair cost. But you could look for flange mounted designs where the pump is actually not mounted to the base plate. And that looks like this on the video here, where the pump has then an engineered flange that has an instant alignment, which then minimizes or reduces that concern. So you don't have to think about the alignment anymore, because once you bolt this pump back on, it is instantly aligned. And there you can see the flange goes on with the motor reducer there. So there are techniques and equipment out there that makes this easier for you. On the next slide here, I will guide you to the Unibloc Tech website. There are additional information there and additional tools. If you have questions about something, some things may be answered here, or please don't hesitate to reach out to Unibloc. We will be happy to guide you and apply our knowledge, what we know in the industry, what we think might be working best for you. And final slide here is to share with you the Unibloc Tech consists of a couple of different brands, such as Flowtronic, one-nut pump, the standard pumps, and also the Unibloc pump. And hopefully I was able to guide you a little bit and give a couple of key highlights of what I have learned so far. And if you have then questions, we will talk about that now.
Thank you so much, Pella. We really appreciate that presentation. I'm just going to switch over to a different screen now while we get our questions queued up. And someone has asked if the presentation is going to be available via a recording, and the answer is yes. You will receive an email either 1 or 2 days following today's presentation. It should be just 1 day with a recording of today's presentation, including this Q&A session that we have now with Pella and with Callie. And we're going to go ahead and ask a couple of questions here. One of the questions I have for you, Pella, is it recommended that you run a pump during CIP? And if so, at what RPM?
Yes, that would be recommended. The normal way to do that you install a bypass, because as I showed you there earlier on the slides, the production flow is maybe 10 gallons per minute, but the velocity required needs 25 gallons per minute. So the pump itself will then be a restriction. So the way around that is with a bypass, where you leave some fluid through the pump, but the majority of the fluid goes around the pump to keep up with the velocity. But while you're doing that, you do run the pump as well. But all the fluid is not, the CIP fluid is not going through the pump 100%.
Okay. And another question here, can you use a lobe pump as a product pump and a CIP pump?
Yes, you can. Some industries tend to do that. Most don't. The reason why you don't do that is because you will have to oversize the low pump in order to achieve that higher flow rate for the velocity. And that becomes a little bit more pricey. So that's where you use a booster pump instead. That is a less expensive pump to create that higher flow rate. But it is possible, but then it's basically 2 applications in one, where the low pump has to be designed for the higher flow rate and pressure, which would be the CIP.
Okay. And about how long does it take to dismantle one of the COP pumps for cleaning?
You're looking at a Unibloc CIP versus a COP pump. I would estimate it's about 4 to 5 times faster to break down and assemble a COP pump compared to a CIP low pump.
Okay. All right. Paul has a question. He asked if, have you experienced any vibration with the lobe pumps when running at high speed? He said it could be maybe caused by slip.
Maybe from cavitation. So normally on the highest, all the low pumps, they have a max RPM rating. So you don't want to over exceed that. But then what you may believe would be vibration could be the cavity. If you go at very high RPM, you got to make sure that the fluid itself is keeping up to get into the pump. Otherwise, there would be cavitation. There would also be some type of vibration from that.
Okay.
Yeah, and if I can add to that too, I don't think slip would cause any more vibration, but also the size pump and the size of the rotors makes a big difference. As far as if we run a smaller pump, you can run it very high RPM compared to a large pump will make more noise and vibrations. But you can also choose different kind of rotors. For example, tri-lobe seems to be more acceptable to running fast than bilobe, for example. But generally, the bigger the pump, the more vibration.
Okay. Now, Robert has a question here, and I'm just going to state that he has a lot of great detail in this question. So this may be a question you're going to want to answer for him following the presentation. So Robert, if you're still on, this is something they can reach out to you about. But I know he's referring to the potable drinking water pumps and the NSF and ANSI 61 requirements. And I think what he wanted to know was, are there requirements similar to this for the food industry? Do you ever see standards like that applied to your pumps when not pumping potable water? I don't know if there's some standards that you could talk about.
Those are standards I am not familiar with, to be all honest. I would, but it's anything that goes into your body as a human consumption, it should fall under the FDA and FSMEA, but there may be deeper standards here for some additional requirements that I'm not familiar with.
Okay, yes, I'll have you take a look at this question. He has some interesting facts about just the seals and the chemical contaminants and things like that. So I'm not sure if it will relate to here, but one last, oh, sorry, Khaled, did you want to add in?
No, I just wanted that.
Okay.
We will definitely want to take a look at it and see,
Sure.
maybe we misunderstood something there, but we will dive into that one to get back.
Great. And one last question we have here is, are low pumps able to pump both product? I think we asked this, both product and CIP media, but I think they were asking, is a twin screw pump mandatory? What are the risks?
Yeah, twin screw can also work for that. That's kind of the idea with a twin screw as well. Can do 2-in-1 versus a low pump. You can also do 2-in-1, but we have to size it larger than you need for the product.
Okay.
Yeah, the RPM range is so much higher on this twin screw pump than a low pump. So that's the benefit.
Yeah, that makes sense. Okay, well, I don't see any other questions coming in, but to all of our attendees, don't forget that you can email me for a certificate of participation. I put my email in the chat. It's jdking@cahabamedia.com. And Pella and Kala, thank you so much for being here with us to answer our questions and to give us this presentation today. We really appreciate it.
All right, thank you very much.
Thank you for listening.
Thank you. Take care, everyone.